Hi, welcome to another Blue Lightning software development stream. Again, looking at Unity C# development. Came across this thread on the forums. Obviously, I've looked at this years ago, all this kind of stuff. Well, in the short time I've been doing Unity anyway, but here we go. What I want to do is just lift this guy's code. It's a test to see if test to see is Invoke faster than Coroutine. It obviously is. I think everyone knows that an Invoke is. I have to rename these to the file name to get it a mono behavior to work. It has to be the same name. Now, what it does is it kind of you have an invoke method that is just taking this counter on the object here, repeating and increasing it each call, and when it's greater than repeat number, it's finished. It goes to here and it records the time from a stopwatch that is started here at the beginning of the test. It then invokes all those invokes methods with the delay, and yeah, so you get the time here is the call time. Now this was interesting. What this is the call time. So this is the overhead of calling the invoke methods. What we got here is the same for a coroutine. It is a very similar thing. The coroutine method just has that delay, and then the same thing, it just increments that counter, and when it's greater than that number, it goes to coroutine finished, records the time and prints it in debug. Okay, so what I'm going to do is add that as an object, start to this game object, and just call both methods. So I'm going to call the invoke test and the coroutine test. And these astonishing results. What you'll see is that what it does is not recording this time of the invoking. The same with the coroutine. It's the time that it took to call these, to, you know, because thinking in terms of Unity single thread, it's all jammed until it gets past here. I think the coroutine is actually jammed until the yield is called, because what you see, it definitely is affected by this yield creation. That's where we'll look later. And the invoke is the overhead of calling the invoke and leaving it going. So you come up with this time that is after it has called all these coroutines. It's not including the delay. There is the same delay present in both. Within the coroutine, this delay here in the wait, and in the invoke, the delay seconds there. So, but this is purely the overhead of calling those functions in each. So, right, let's have a look at how this comes out. Load of junk in here. That's bit code, project reuse. So, I'm not sure that mine re-imports 100% automatically. I'll probably go to switch stuff, the domain thing. I'm not sure. We create test object. We add that component, the test stuff. We got that delay. It's set to run. And let's just press play. Let's have a look. What came out of this? Take a while. Nothing. Oh, there we go. Right, so we've got some times. Okay, let's write these down. Let's try and just cut and paste them. Back to front. But yeah, we've got the 309. I think the only thing that's really important is that these should be first. So there we go. Right, 309, and notice this number, the completion is exactly the same. It's like you got the delay. I'm not sure, it just is exactly the same. That after, it kind of makes you think about what it's doing, because it's doing exactly the same code in each case. This could be cut and pasted from the coroutine to what's inside the invoke. I mean, it's identical bit of code that is executed post delay. So yeah, they come out, but it's in the coroutine is post this line. I get the impression that the thread is jammed until the first yield when a coroutine is called. You might want to check that, but that's how it kind of pans out. We'll run another one. We'll just run another one like this, run it again, just to see consistency in these times. Be a bit scientific. We've got 2 samples now. Right. So let's do 287 and 309. And this time we got 1990 and 1945. Okay, these are coroutine. You could say more, but they're in the part 300 and 1990 something. Okay, so what is jamming with the coroutine? That's kind of like the overhead of creating the coroutine a million times. Now, people would say that's stupid to even care about that. What's that? A million, that divided by a million. Okay, yeah, don't worry. This to speed up your coroutine a tiny bit, you can create the wait for seconds kind of globally, well, within this object. You can have them completely, you know, just, this could be a static constant. It has to have the delay for seconds, which is public variable, so it's probably best to do it here. Do we declare wait for seconds? Wait somewhere. So declare wait for seconds. Wait here. See, we have a wait for seconds object here. We set it here to delay for seconds, and then we we reuse it in all of them. Now these are totally, you can have these as a static thing anywhere attached to anything. It can reuse that same wait over and over and again. It doesn't jam. It's not waiting for that wait to release. It's just some information in that wait that is kind of reused here by all of them without any delay issue for reusing the same wait. So let's have a look. Let's go to project, re-import this. Let's run it again. So we did here, we used the same weight each time. Wow. Do you know what? I did a variant of this earlier and it looked like that was having a really good effect. Maybe it's nonsense about that. No, I mean, it's not showing up as having any effect there. I kind of did one earlier where it looked like it did. Where it may have effect though is something else I wanted to test. The kind of garbage jam. I don't know what his was doing there, to be fair. Okay, so now instead of in the start calling all of these, yeah, what we could do, except we will create that wait there to the delay seconds. That'll be done in the start. Every update we could call this, yeah. Now be really careful. Alright, so we'll have to set this on the object before we run, because if you did this every update it would explode pretty quickly. But this is going to go through each time, every update, and call a load of those invokes, and we'll get all the information coming out. In fact, I think what's best to do is to run them one at a time. So this would be with coroutines. Get the profiler out and have a look at what's going on. I have to stop it before I recompile that. Let's do that. I always wind up re-importing these, and it doesn't automatically sometimes. Depends what your settings are. So that's re-imported. Now just get this down to like, alright, let's start with it. Does that sound heavy? 1,000 every second, every update, every frame to 100. Let's see what that looks like. So that's 100 repeats of the coroutine with half-second delays, so they're running in the background. And we're just going to play every frame is doing 100 of those. We're going to get a lot of console debug spam, but let's have a look. I don't think 100 is going to blow up. Let's just be a lot of spam. Oh, it doesn't. It's not even registering 100. It doesn't add up to a millisecond even. But let's get the profiler out and have a look. What do you think's going on? I don't know, the difficulty is, right, when you run a profiler in editor, is that massive spike just garbage collection? Or is it just like the editor thing? Because it's all running along nicely. Alright, hold on, let's try and overload it. I think it's the profiler in the editor anyway. I don't really get it. You tend to get loads of junk just for running the editor. Might be me. Oh wow, because now it's getting some numbers. It's kind of killing itself now. Yeah, 1,000 every update. Coroutines is doing stuff to it. 2 milliseconds and 2 milliseconds. Just the call is getting like a frame rate. It's jamming up. I think there's too much going on. Just think about it. With over 1 million previously, how many frames in half a second? At 60 it would be 30,000. So it's not as bad as that million running at a time. Is it possible to see what's going on? What is that spike anyway? Whoops. It's going to be really hard to test, I think. I could have a nice Boolean in, can I? Okay, so we can switch between which one we're looking at now. It's all in that update. I'm really not sure. I've got to think about this maybe some other time, come up with a good method. This will be using Invoke. 1,000 is definitely kind of jamming up. I'm not sure how we could see the difference. What's going on? I'm not 100%. That stopwatch has ceased to make sense for the complete execution, hasn't it? it's not really worth taking, because I mean, just this, every time I call that, actually the stopwatch itself is going to take a hell of a long time. I've created 1 million stopwatches in this example. When you stop, I say, oh my god, 1 million stopwatches. It's got a stopwatch now. So restart, is it restart? Yeah, restart. Let's do restart. That makes a lot more sense. It's not no longer 1 million. So this second number doesn't actually make sense anymore, because invoke finish number. There's not a lot of point in actually even invoking finished anymore. So, you know, it's going to do that counter anyway. So I'm rubbish at using their profile. It always looks like just some certain tasks, yeah, it is really useful. I just haven't really focused on how to. I should have done before this. Look at part of the profile is really revealing here, because it just always looks like a big editor loop kind of thing. You got this. This is like it is running the invoke test. This is invoke now, chugging away. Yeah, is it? Okay, bonkers here. I think that's generally mad. What's we re-imported what we had. Oh, because the finished gave us the invoke calls elapsed. Which we could have just done here. This example. Okay, so here we go. I'm not 100% sure what numbers we get out of this. This is the basic overhead 1 million times. The difference between invoke and coroutines. What I'm suggesting is there's a huge difference we can't see in the garbage collection. That would only really become apparent here. So we're going to look at that. But it's much harder to measure, I think, the complete impact of anything like this due to garbage collection, etc. These are all zeros. It picks these up if you change these, doesn't it? Yeah, now we've got something registering. $10,000 of these per update, per frame. It's kicking out 10,000 of these. What's that look like? It made sense till I opened it. Do you see what I mean? It was ticking along quite nicely, but this is the graphic. I think this spike is to do with the graphics of the profiler itself. That sounds stupid, but watch. Look at the left of the graph as it whizzes past. See what I mean? This was that. Oh, I now clicked on it. Yeah. Okay. So this was before some crazy garbage collection for the graphics of the profiler kicked in. Player loop, this kind of thing, 363. Alright, so that was 10,000. It was running at 60 FPS, yeah, that's like the baseline. The minute you switch to, I think that's to do with the profiler rendering. I'm not sure, I'll have to investigate, but oh, we could have changed this here and it would have actually worked. Didn't need to restart. I have just done that. Whoops. Alright, so we switched to Coroutine. Much higher numbers. Alright, it's jamming now. And let's have a look at, they were around about. Much larger numbers. So you can see, like, if you did this every frame, this is 1,000 coroutines. I think I had the invokes up to 10,000. Let's look at the profiler. Still that's way fast because it was 1,000, not 10,000. Let's try Invoke at 1,000 per frame. They were around a bit. Just get past that half second. It's all clocking up somewhere. Whoops. Yeah, I mean the underlying rate, I think if you ignore these spikes, actually, it's hard to differentiate what is created by this render of the profiler. I think, if that's what it is. But look at the left as it whizzes past. It's usually it's nonsense, right? But it's got a baseline underneath of like 1,000 FPS. And just that baseline, still 1,000 FPS. Animation, I mean, what's scripts? Is that saying is that blue for scripts or it's the rendering seat. So I switch everything off. So we got there's no rendering, garbage collection, VSync, global illumination, others, animation. It's not animation. That is the script. So it's coroutine 1,000 per update. It's a bit weird. That's Invoke. That's Invoke. Actually, more spiky kind of thing happening there. This is the coroutine. I've got this horrendously wrong. I'm with the baseline of the coroutines. What must be scripts then is that blue is scripts. It's taking us up to 250,000 coroutines. Per update, per frame. Now that's interesting. That's Invoke. Somehow got really spiky, but the baseline is down here. Frame rate. Are those the same spikes? These are the spikes I associate with the profiler itself and the editor. I'm not sure if it's others. Yeah, take out others, alright. Just garbage and scripts. It's still got a spike. This, oh man, profiler. So that's using coroutines. I switched to Invoke. Mega speed with a bit of a spike now and again. Whatever others are in this instance. So others are quite a lot of it. wizard of the profiler. I don't know. But it becomes evident, like, even if you include the others, that the baseline kind of thing, well, there's some spiky behaviour up to 250, but this is the coroutine with spikes coming up. Those spikes are always there, unless you remove others, I think. And they're just there with the Invoke. That's Invoke. Could be super fast. Okay, so if you were using, for whatever weird reason, you were calling 1,000 invokes per frame, it's noticeable. Let's up that to 10,000. Why anyone would do this, I don't know. But that's the coroutine. So that's 10,000 coroutines per, and there is a garbage collection spike. Okay, so that's the garbage collection. Does that make sense? I would expect a lot more garbage collection. Maybe I just don't understand what's going on with the others. So you're down to 30 FPS on just running 10,000 with the occasional garbage spike. Profiler flush counters. Do you know what that is? That's profiler flushing its counters all the time. That could be, what is others? Editor loop, all this kind of stuff. I mean, some of the other weird stuff that's in there. But losing sight of the point, this is coroutines, really stripped down. See, quite heavy. This Invoke, if you're doing mad amounts per second, then it would become apparent. There's more of this scripting spike in the Invoke. That must be the timing or something. Maybe it bunches up the timing every frame, so at the end of every frame, who knows. There's profiler flush counters. That's all there. It's in there somewhere. What's going on? So we got 94%, 18 script run delayed, fixed frame rate. Yeah, that's update, behavior update, fixed frame rate. Is it saying that it tests all of these invokes and whatever only on a fixed frame rate? So that is when they're actually testing the invokes at that point, possibly. Totally guessing now, but script run delayed, fixed frame rate. It could be it bunches up every frame of the fixed frame rate. That doesn't make sense either. I mean, what is the frame rate at that point? It's not fixed somewhere, is it? As fast as it can run or something. I'm just making stuff up now as to what that spike is, but it could be some kind of bunching of the actual delay handling, because it could be working out that its current frame rate, it's doing a fixed update because it's all the time it's got, and it's at that point that it calculates the invoke handling timing, maybe, because it is something along those lines. Every frame it assesses what it's got to do. That's a coroutine. Look, you lost a lot of FPS, but that's with something dumb like 10,000 per frame. So impossibly locked it up, kind of limiting yourself to that, you know, with that number. Obviously, Invoke, I'm not seeing like some crazy garbage collection happening. It's all just the scripting handling. I'm not even sure how to time that, but yeah. Anyway, it's there. That's the difference between Invoke and coroutine. From the overhead, it's really hard to tie this off against stuff like some of what I've been using, like a Coroutine, that hard to put it into context, because creating those would actually probably be worse. So you create them and store them. I doubt you could even create that many. Like the number of coroutines being created here, 10,000 a frame is loads. But if you just got one that you kind of use consistently, it's like storing a coroutine. There is a garbage spike there. Should just let it go for a bit, see if there is a load of garbage spike in. You never actually see something as garbage collector. But yeah, it's hard to compare. It says a nano overhead, what's storing one. There's quite a consistent garbage collection spike that would grind you to a halt almost. Look, it takes it in this example of 10,000 coroutines, which is stupid. You know, per frame it's creating 10,000 coroutines. You do get this huge garbage collector spike. The only other thing there is this comes round when it comes round. Not sure what that goes in. Where would that be? But that is a huge garbage collector spike. Garbage collector collect is most of that, half it, you know, halves frame rate, time, your time is doubled for that frame because half of it is garbage collection. That's the garbage collection creating a 572 millisecond frame, which just jam your game. If you did create 10,000 coroutines, so we can see that's coming through. That's the garbage collector cycle. It's about the timing that we're waiting for it. It's quite slow, isn't it? I mean, I should really read the book on this because I don't know, but it's got so slow now. What's up with that? Until that garbage collector came in, that was dying, that thing. Or was it? No, it's just the scale. I'm mad. It was at 60 FPS, and then it just one chunky garbage collection, and then like the frame rate average massively reduced following that. Let's look at Invoke, see if that creates a garbage collector spike visibly. That just seems to have these. I think that's the timing handling. These spikes here, I think that's the timing handling of the frame. Kind of calculate and say, oh, my invoke is due when. You know, it does that for all the invokes. It's something like that for a coroutine. Okay, you'd have to read the exact documents to understand it completely, but it's along the lines of the invoke is calculating is it due to perform that task then, and that's those spikes were calculations of that kind of thing. So if you look here, test stuff, update, log garbage, there is some garbage, micro garbage going on in there. But when you get to these, the coroutines delayed calls, that's what it's called, invokes. So these are the invoke delayed calls actually performing their tasks, which sounds bananas thinking about it, but yeah, that's something to do with the timing of the invoke is being bunched up in these. And virtually no garbage collection coming through, and we've already removed the weight issue. I can almost put a switch here. If you're so bored, there's probably no garbage in that invoke. So what we're seeing is that spike coming through on garbage collection. So I quite like that these mono behaviors, you can change these live and actually works. Use same weight. So we could go here in the coroutine. Do that. Or we can go back to using old friend. Create a new one every frame. Okay, so we can now flip between these. Have a look what difference that might make. Totally bored here. Yeah, what time is it? Talk. Yeah, okay. Right, that was imported, so we'll run it again. Using Invoke, we're going to switch to the coroutine. Switch to coroutine, much heavier on 1,000, much heavier on 1,000. All right, okay, so it's just that spike. Look at the spike. Wait for it. What's it running like? This is coroutine 1,000 per second. Boom. Oh, it takes you down a bit. All right. The Invoke, the weird timing of the Invoke. This is 1,000 per second. All right. 1,000 per frame. Sorry. This 1,000 per frame. That's the 1,000 FPS line. This is with. So now we're using the coroutine 1,000 per frame. We are way above the 1,000, so it is slower, much slower. You know, on 1,000 per second. What circumstance you find yourself doing 1,000 coroutines per frame? Sorry, I keep getting that wrong. Per frame, not per second. The garbage on the frames. Yeah, because we're not using the same weight. Did you see that garbage collection spike? Wait for it. Garbage collection totally bunches it up for a massive spike wave incoming. Where is it? There we go. Yeah, it takes you right down. Now, that took us under 30. Let's use the same weight. See, it might take a bit of 2 times to feed through. Okay, so we wait for the garbage spikes. Whoops. Boom. Same kind of spike, actually. This is going to be hard to measure. Stick it up to 10,000. So we're using the same weight. That spike, I didn't actually wait, did I, to use it twice? So, because it could have been, with these half-second delays, it could have been the old one. It could have been the old timing. It's just this massive garbage spike takes you up to about no frames. I think it does take you to 2 frames-ish. Last time, 500 milliseconds the last time I looked. It's hard to measure the impact of this in is that getting worse? Let people go on about it, this being the one, the weight really making a lot of difference. It's hard to actually say that it does make that much difference. $674. Take some garbage spike measurements. What was that? Pretty secretly cleared out its garbage collection when we weren't looking there. huge one there. Okay, let's switch to using the same weight. This one's going to be mixed, so we'll look at the first one that comes past. So this is using the repeatedly using the same weight for seconds. That's what that means. Could potentially ignore the first one. It could be mixed. Why doesn't garbage collect very often, does it? That looks huge. That looks enormous. I think when you pause it as well, it's probably somehow malfunctions. There's probably all kind of settings you could put on this as well, make your garbage collect better, but never mind. Yeah, I mean, I can't tell the difference actually. So, I mean, can we see, all right, 10,000 frames, all right, this is using the same weight. Let's just look at a kind of baseline FPS. We're about 40, 50, what's the frame per frame? 27 milliseconds a frame. There's a patch when it kind of averages out, something enormous following the garbage spike. So I'll mess with that anyway, but let's wait. So we were at 27 milliseconds. Once this goes past, I think that's like an average. It looks about the same. That's with using the same way, garbage spike. I mean, we could be measuring our post-garbage spike time or something. 29 milliseconds, about the same. Yeah, it looks the same. Does the garbage... That post-garbage spike, alright, I'm just saying crazy stuff now, looked less without this. Let's have a look. Wait for our garbage spike. And the bit after the garbage spike, the length of time, is that just bananas? It should be the same every time. Yeah. Let's wait for that pass through. Let's have a look. 48, 46. Does this want to be a bit mixed? I should have clicked that while it was paused. $37. I might be better reading that kind of chunk after the garbage collection spike. I'm mega bored people here, which, you know, I'm going to have to stop in a minute. It's gone too far. But, you know, I mean, it just makes you think. I mean, on a nano level that you're probably completely wrong to even think about is 43. Switch back to the old weight. So you had 37.43 readings off that. This is with the... Yeah, it looks the same. I think that one's wrong anyway. That's 49. It does keep coming in at 49. It could be a difference in the garbage collection using the same weight. Okay. It could be measurable. I think you can actually measure in these kind of readings for the original testing. I think it is possible to actually make a measurement there. What's up with that? What happened? I'll stop it somehow. I killed it. No, it's back. There we go. this is 49 again, I'm going to conclude that 45, maybe that's a bit high garbage. Anyway, so that's some interesting tests, right? That Invoke, obviously, you know, if you're doing a huge number of them, for whatever reason, I'd say even at 1,000 per frame, which never happens, does it? Who does that? Who creates 1,000 per frame? Even, you know, whatever you're doing, that spike is way. I'd much rather have invoked. 100 becomes nano level, becomes, can't even trace it. 1,000 frames, 4,000 frames, 10,000 frames a second. It's absolutely, well, yeah, no, the coroutine at 100 per second would take you out of the 4,000 frames per second. It's really interesting. I think the fastest thing you could probably do is create an invokerizer, but you notice this timing spike is happening. But where was it? That's the peaks of the timing spike. It's not. Oh, there we go. That's it. Yeah. Anyway, we're going on. I'm gonna have to